Hi guys, welcome to my YouTube channel Study with me. Today we are going to look into digital signal processing in a whole new way. In this video, I am going to talk about how the concept of vector spaces are used in digital signal processing. Basically, I will give an introduction to vector spaces and its importance. First of all, let us get a sense what a vector space is. Here, I am going to show you some examples. At the end, I am pretty much sure you will get the intuition what is the role of the vector space in the digital signal processing. Okay, here we go then. First, as you can see, we have graphically illustrated the two-dimensional vector space. Here, the important fact is we can draw the space. Actually, we can draw the vectors which are the elements of the two-dimensional vector space. Okay, right. Next, we have the three-dimensional vector space. Same as before, here also we can graphically illustrate the three-dimensional vector space. So, after going through the examples, I am pretty sure you guys got the basic understanding. Actually, the sense what is this vector spaces are. If I go for a further explanation, the vector spaces is like the environment that the Lego blocks are sitting. Okay? Actually, in this example, the Lego blocks represents the basis vectors. But for the time being, don't worry about it because later in this video series, we will be looking at it more extensively. So now, as we identified what is a vector space is, let's find more about vector spaces. The first question is, why we need this? Okay, in DSP, there are four main categories of signal. First one is finite length signals, then infinite length signals, and periodic signals, and at last finite support signals. I'm pretty sure you're familiar with these type of signals. Okay? Then, to represent these signals in the domain of digital signal processing, we need a common framework. For that, we use vector spaces. However, as we are proceeding in this video series, you will identify how efficient this framework. Okay? If we talk about the speciality of vector spaces are very general objects, which means it is a fundamental mathematical structure that provides a framework for studying and understanding various mathematical objects and systems. Then, vector spaces are defined by their properties. Again, the elements and operations of the vector space must satisfy axioms of properties. Okay? And finally, when the properties are satisfied, we can use all the tools for the space that we are interested in. After learning all of these things, you will ask, okay, now why vector spaces are in DSP? I know that is a fair question, but for the time being, I'm going to say it provides a same framework for different types of signals and easy explanation of Fourier transformation and easy explanation of sampling and interpolation, and then useful in approximation and compression, and etc. Just as vector spaces, we are talking about the function space under the same topic. Believe me, there's nothing different, right? However, for the time being, let all your worries rest in peace. When you go to the video series, everything will come into light in the same way it was for me when I was learning all of these things. Okay? Right. Here we go again. Now, as you can see, there is the capital L and little 2 which is subscript to it. Here, capital L means the Leibniz norm, right? And the little 2 which is subscript to it means the norm is calculated using taking the square of the component and then we sum all the component with actually we sum the squares of the component and take the square root, right? And within the parenthesis there is a range -1 to +1. It is a standard, okay? However, there is x equals x of t, which is the sine function, which is a function of variable t, and t belongs to the range as we discussed before -1 to +1. Okay, simple as that. No big deal. Up to now, all the vector spaces we saw can be graphically illustrated, which means we can draw them. But what about the spaces I have mentioned here? Just think about that and you will definitely understand these spaces cannot be simply drawn or graphically illustrated. Of course, unless you are an alien, right? Okay. So now we are coming to discuss about the properties of a vector space. As you can see, here are the properties of a vector space, and I'm not going to explain these things because I'm pretty sure if you are learning digital signal processing, you must have learned these things in your maths modules. Okay, so this is your task. Go home and understand these properties, right? They are not very complex things, just simple properties. Okay, right. So friends, if you like the video, hit the like button, and if you want more, crash the subscribe button, and if you are pretty much excited, share it. Now, the next video is about the examples on vector space properties and the scalar tool, which is the inner product. So, let me rest until the next time. Thank you very much.